Okay. Then let me briefly introduce the idea of machine learning. So let us think about the example. If you want to train a baby to recognize some objects, how to train the baby? Normally, at home, we can show many image cards to the baby. Say, show the baby, oh, hey, baby, this is a bus. And show another card, hey, baby, this is a dog. This date are called the training date. We show the data of the training date to train the baby. And each image has the no date and no response. So we know this is a bus. Tell the baby this is a bus. And tell the baby this is a dog. And we train the baby for multiple days. And then when you take the baby out and the baby sees some new things, and for example, the baby see a school bus, can know that, oh, this is school bus. I see that, I saw that before. And in this example, in the machine learning, the machine is like a baby. So we can show the training date in the training set to the machine for many, many iterations. Each image data, we can have the no data and no response. So after training, the machine can know which one is a school bus and which one is a dog. Okay, this is some behind the framework and pipelines here. So let's say this is a school bus image. So in the computer science, image data is just some numbers. We make the red, green, and blue numbers for different colors. And that means this image actually does some numbers. We fit these numbers into the AI model. We do the feature extraction and decision making, and do the prediction. From left to right, this is called forwarding. Forwarding is for the prediction. And when you have the prediction, because you have the image data and the no response, so we can measure the inconsistency between your prediction and the no response. So sometimes this no response is called the label, so ground truth label. We compare the prediction and the ground truth label. We know how large is the inconsistency. So this one is called the loss. So based on this loss, we can do a backward propagation to update the model parameters. We do backwarding for training to update the AI model parameters. And in this way, we can train the model. We repeat this for many, many iterations, and we show some other data in the training set. And in this way, this model can be well trained. So you can have a pre-trained model. When you see a new data, this new data I have never seen before can be fed into the new model, can be fed into the pre-trained model. This is forwarding for the pre-trained model, this new data. And we can have the predicted response. That's a dog. Even this machine never see this new data before, but because of training, this machine can still recognize this is a dog. Okay, and then let us introduce deep learning. It's mainly about the deep neural networks. So this word is compared with the traditional neural network. Traditional neural network has 3 or 4 layers, but deep neural network have many iterations, many layers. So for example, 152 layers, and among them, convolutional neural network is a representative one, CNN. It's very effective for the computer vision tasks. So look at this example. An image is, we know that image is just some numbers. We fit into this CNN. We do the convolution to extract the features, and we do ReLU for the activation, and we do pooling for the dimension reduction. So we can extract feature from low level to high level. Low level features mean some features like color, texture, and the shape and edge. So we can still see the boundary and the contour of the cars. And the high level means these features are more close to a human being. So it's called semantic features. These semantic features are used for the classification. They fit into fully collect layer for the classification. So for example, this image has the largest confidence to be the car, second largest confidence to be truck. So we know we can predict this is a car. So this is end-to-end system from the input image to the output class. Let's say we are doing an image classification problem. So this end-to-end deep neural network extract the feature that are most effective for the final classification task. So they do this one in a unified framework. Traditional machine learning may design some handcraft feature and extract the feature independently, separately, and then use the extract feature to do the classification or prediction. So actually it's two steps. It contains two steps. One is the feature extracting and then do a prediction or classification. But this deep neural network make it into unifying the end-to-end system. We do a feature extraction and the classification together. So the feature will be quite useful for the final task classification. So this is deep learning. So to make this simple, you may just think deep learning means the machine learning using deep neural networks that have many more layers.